Sketch the graph. Describe the transformation for the parent function f of x equals a times b to the x, where b is the base of the given problem and a is its multiplier. Identify the starting point h comma a, the critical point when x equals 0, domain, range, and asymptotes. So our parent function in this case is going to be e to the x. So here's a picture of that graph right here. Our a is 1 because there's nothing here, so we say that there's a 1. B, our base here, is going to be e. H is 0 because we don't have x plus anything, so there's a 0 there. And then there's no vertical shift, so our k is also 0. So our starting point, h is 0, so we have a 0, and our a is 1. So that would be our starting point. So we go ahead and label that on our graph. Our critical point in this case will be the same, but that's not always the case. X is 0 here, and when x is 0, our y is going to be 1. And our asymptote, that's going to be our k value. It's going to be at y equals 0. So you can label your asymptote like this. You put a dashed line across where the asymptote is going to be. An asymptote is just an imaginary dashed line where it never touches. It's never going to touch that. As small as it gets, it's always going to be 1 less than that 0. Domain is going to be all real numbers. No matter what number you put in for x, you're going to get some kind of output. Now, for that output, since we have an asymptote at y equals 0, well, y is never going to touch 0, and it's also never going to go below 0. So our range is only from 0 to infinity. So using this example, let's go ahead and try an example from the homework packet. So if you go to the homework exponential functions, let's look at number 10. So on this one, we're going to first identify what our a is. Again, a is going to be our multiplier. That's going to be 4. Our b, that's our base, is 2. Our h is 0. There's no horizontal shift. And our k is also 0. There's no vertical shift. So our starting point, if you look here again, it's h comma a. Well, h is 0 and a is 4. So we're going to go ahead and graph that on our graph. Our critical point, again, is when x equals 0. So this will always be 0. And if we plug in 0 for x here, well, a thinks the 0 power is 1. 1 times 4 is still 4. So this is both our critical point and our starting point in this case. Our asymptote, again, is the horizontal line. That's our k value. K equals 0, so we have it at y equals 0. So we'll draw our dashed line. Again, we do all this stuff before we even graph the actual line. Well, let's go ahead and graph it now. So this is going to be a growth. For 1, this 2 is greater than 1. If the base is bigger than 1, it has no kind of reflections or anything, this can be a growth. So we could go ahead and note that. If it was something like a fraction, like 1/2 or something, 1/4, 1/5, 3/7, that would be a decay. But 2 is bigger than that, so it will be a growth. So we can go ahead and sketch a line from there. Our domain, again, is all real numbers. Our range will be the same range as right here. We have from 0 to infinity. Basically, our range is going to be from whatever k is, which is 0 in this case, to infinity. And that'll only change if you have some kind of reflection or something. Or if your asymptote, of course, changes, but that would make the k change as well. So go ahead and try the rest of these on your own or in small groups, and let me know if you have any additional questions.